Okay, today we'll start the chapter number 17, that is circle theorem. Okay, so for the circle theorem, first of all, we have to start the starter activity. So, what is the center of the circle? First of all, center of the circle is that point from which the all points are at the same distance. Okay, what is the radius? The first is the radius of the circle. The radius of the circle is the distance between the center to the boundary of the circle. Okay, so first figure represents the radius as the red line. Thus, in the second, the red line shows the circumference of the circle, right? In first figure, the radius. In second figure, the circumference. In third figure, the center of the circle is shown as the center is red. In fourth figure, you can see that a small patch is red. It means that this is the arc of the circle. Arc is basically a small part of the circumference of the circle. So it means that the third is the center, the fourth is the arc. Okay, fifth is the diameter. Diameter is basically that straight line which connects the 2 points of the circle and passes through the center of the circle. Okay, so this is the diameter, this one. The next one is sixth is the chord. Chord is same like the diameter, but it is one less property, that is it uh, just meet the 2 points on the circumference of the circle, but it does not uh, passes through the center of the circle. So this is the chord. The seventh is the tangent of the circle. Tangent of the circle is that line which touches the circle at just one point. Okay, this is called the tangent of the circle. Next one is the sector. Sector is basically the area of the circle in which the and one uh, two radii and one arc is used. Okay, in the third one, last one is the segment. Segment is the area subtended by the chord and the arc, right? So these are the terminologies which are using in this chapter. So first topic of this chapter is tangents, chords and circles. In this section you will learn some theorems about circles and then use them to solve problems. The theorems are uh, concerned with tangents and chords. So in this topic 17.1, we use some theorems which are about chords and tangents of the circle, and that helps us to solve different real life problems or different simple problems. A chord is a line segment joining 2 points on the circumference of a circle. Simple, which we have learned in the starter activity. And a tangent is a straight line that touches a circle only once. That also we have studied in the starter activity. So the first theorem is that a line segment drawn from the center of the circle. So first of all, a line segment drawn from the center of the circle to the midpoint of a chord, right? To the midpoint of a chord. This is the center of the circle, and we draw a line on the midpoint of this chord AB. Intersects the chord at right angle. It means that intersects the chord at right angle. So this is the theorem. This is your first theorem. If M is the midpoint of AB, so AM is equals to BM. This is understood. Then these two angles will both be right angle. This is the 90 and the other one is also the 90, because the angles on a straight line are added up to 180. Okay, also the next one is a tangent and radius meets at right angle. This is another theorem. A radius and tangent meets at the angle 90 degrees. The fact that the radius and the tangent meets at right angles is very obvious when one is vertical and the other is horizontal. Let's suppose we just use the radius is horizontal, it means that the tangent is vertical. If we use the radius is vertical, then the tangent is horizontal. Okay, so this is on the base. We can also draw at any point on the circumference of the circle, but it is not quite so obvious when the situation is rotated like this. For the angle is also 90, but we have not not sure about that which is vertical and which is uh, horizontal, but they both are uh, 90 degrees, having 90 degrees angles, right? The next one is the two external tangents to the circle are equal in length. It means that we have a point outside the circle, right? At that point we draw two tangents that touches the circle at single point. So it means that it meets at radius at 90 degrees. Here is also at 90 degrees, right? So the length of these two tangents are also same. So you can also say that if we draw a line, you can see that this is 90 degrees, this is 90 degrees. One angle is congruent in both triangles. This is radius, this is also radius. One side is also congruent in both triangles. This side is in the lower triangle and this side in the upper triangle. This is a common side, so they are also congruent. So it means that the upper and lower triangles are congruent. That's why these two triangles are also congruent. So if these two triangles are congruent, so this side and this side of these two congruent triangles are also equal or also congruent. Okay, these theorems may be used to help you determine the values of missing angles in circles. When you use them, remember to tell the examiner which theorem you have used. So if you use any of the above theorem, you have to just um, make the reference of this theorem. Okay, here is another example. The diagram shows a circle with center O. PT is a tangent to the circle. Find the value of x. So first of all, here is the PT, that is tangent, x is the angle, and this is 48, that is also the given angle. So you can see that the angle TPO is 90 degrees. Why? Because it is the radius and the tangent, so they are meeting at right angle. The angle OPT is 90 degrees. Angle between the radius and the tangent 90 degrees. Okay, the angle is triangle TOP add up to 180. So this is a triangle, and you can see that every triangle has the angles add up to 180. It means that x plus 48 plus 90 is equals to 180. So x plus 138 is equals to 180. So you can see that x is equals to 180 minus 138. It means that x is equals to 42. So it means that this angle will be 42 degrees, right? So this is a smaller example. Another example is that the diagram shows a circle with center Q. AB is a chord, and of the circle M is the midpoint of AB, right? M is the midpoint. It means that this angle and this angle are 90 degrees. Why? Because we have studied the theorem that angle AMQ is 90 degrees, radius bisecting chord. So we have to find the value of y. So this is 90 degrees. Again we use the previous knowledge that the sum of all angles are added up to 180 into a triangle. So y plus 62 plus 90 is equals to 180. When we simplify it, your answer of y is 28. This is your solution.